Section 6.5, Rhombi and Squares. And we have 4 learning targets here, and they're the kinds of learning targets we've been having. We need to know properties, okay? So we're going to know and use the special properties of a rhombus, and then we're going to flip that around, and we're going to know and use the properties that ensure that a parallelogram is a rhombus. We're going to know and use the special properties of a square, and then we're going to go the other way. Say we're going to know and use the properties that ensure that a parallelogram is a square. All right, so we need to know what a rhombus is, okay? So the definition of a rhombus is on page 426. And the definition says a rhombus is a parallelogram, and let's stop there, like we did with rectangle. When we knew that a rectangle was a type of parallelogram, that meant all of the properties of parallelograms applied to rectangles, right? Same thing here. A rhombus is a special type of parallelogram. So all of the properties of parallelograms apply to a rhombus. Do the properties of rectangles apply to a rhombus? No. The properties of parallelograms apply to a rhombus. So it's a parallelogram with all 4 sides congruent. A parallelogram with 4 congruent sides. Okay? And so over here, FGHJ is a rhombus. Notice that it's not necessarily a square, is it? Okay? But we've got a parallelogram, both pairs of opposite sides are parallel, and both pairs of opposite sides are congruent, but not only are both pairs of opposite sides congruent, all 4 sides are congruent. So that's what a rhombus is. Now, so that's one property of a rhombus, is that all 4 sides are congruent. Okay? It's a parallelogram, and all 4 sides are congruent. So let's learn the other 2. If a parallelogram is a rhombus, then its diagonals are perpendicular. Didn't see that coming, did you? So, right there where the diagonals intersect, we get 4 right angles in a rhombus. Now, since a rhombus is a type of parallelogram, do the diagonals still bisect each other? Of course they do. So the diagonals bisect each other, and in a rhombus, they're perpendicular to each other. And then our other property, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Now, that seems a little awkward to read or to say, but this is actually a pretty important idea. For instance, this diagonal right here, PR, it connects P and R. Big angle P is one angle of the rhombus. Big angle R is another angle of the rhombus. And they're, in fact, opposite angles, aren't they? So big angle P and big angle R are a pair of opposite angles. This theorem says that that diagonal bisects both of those angles. Now, since they're opposite angles of a parallelogram, they're congruent to each other. So we've got 2 congruent angles getting bisected. So doesn't that mean that all 4 of these halves have to have the same measure? All right? So for instance, if the measure of angle NRQ, the big angle R, was, let's say 60, and it gets bisected, that'd be 30 and 30. Since this is a parallelogram, big angle P would also have to be 60. It gets bisected, 30 and 30. Okay? Makes sense? Then the other diagonal does the same thing. So angle 5, angle 6, angle 7, and angle 8 all have to be congruent to each other. You think you got it? All right, so what 3 properties do we have for a rhombus? First, we have the definition. It's a parallelogram with 4 congruent sides. Next, we have the theorem that says it's a parallelogram where the diagonals are perpendicular. And the last one, it's a parallelogram where each diagonal bisects a pair of opposite angles. Okay? Let's see if we can use that. All right, let's see. did I get this problem? All right, I got this from, this isn't actually one from your assignment. This is page 427. This is under example 1. All right, they tell us the diagonals of rhombus FGHJ intersect at K, and to use the given information to find each measure or value. All right, so they give us this rhombus, and then they give us a little more information, and we're going to find the length of KJ. So let's see how this works out. The length of FK is 5. The length of FG is 13. And they want us to find the length of KJ. Now I'm going to change the problem a little bit. Since this is a parallelogram, isn't that segment KJ congruent to that one, KG? It is, right? So if I can find the length of KG, I will have also found the length of KJ. Now, so I've used the fact that in a parallelogram, the diagonals bisect each other. Since this is a rhombus, what else do the diagonals do? They're perpendicular. Which means that's a right triangle. And we can use the Pythagorean theorem again. Okay? So I'll call that x. So a squared plus b squared equals c squared. The length of one leg, let's say 5 squared, plus the length of the other leg, x squared, equals the length of the hypotenuse, 13 squared. You with me? All right. So it'd be 25 plus x squared equals 169. What's 169 minus 25? And now I need to take the square root of both sides, don't I? So the square root of x squared is x, and the square root of 144, yeah, we get 12. Now, if it doesn't work out to be a perfect square, then, you know, like if it had been 143, then just write the square root of 143, okay? But we get a whole number. It works out just fine. X equals 12. So what's the length of KJ? 12. Any questions? All right. Same rhombus, different set of information. If the measure of angle JFK, so that'd be this one, is 6y plus 7, and the measure of angle KFG, that'd be this one, is 9y minus 5, find y. What do we know about those two angles? They're congruent, because since this is a rhombus, the diagonal bisects a pair of opposite angles. So the diagonal bisects the angle that it intersects. So that means that 6y plus 7 has to equal 9y minus 5. Go. See what y equals. Y equals? All right, because you would subtract 6y, add 5, divide by 3. All right, so far so good, I hope. All right, let's take a look at something that is from your assignment. So page 431, number 1. All right, they tell us that quadrilateral ABCD is a rhombus, which means it's also a parallelogram. Find each value or measure. So for number 1, if the measure of angle BCD is big angle C, is 64, then what's the measure of angle BAC, this smaller one up there? Answer is 32. Because we know that opposite angles are congruent, so if big angle C is 64, then big angle A is 64. And we know that the diagonal bisects the big angle. So half of 64 is 32. All right, for number 2, if the length of AB is 2x plus 3, and the length of BC is x plus 7, how are we going to find x? Those are congruent. It's a rhombus, so all 4 sides are congruent. All 4 lengths are equal. So 2x plus 3 equals x plus 7. And let's see, it'd be x equals 4. But we're not finished. We're supposed to find the length of CD. Well, they don't tell us anything about CD, so what do? Yeah, find the length of one of the others, right? Because they're all 4 congruent. So if I use that one right there, that's pretty easy. 4 plus 7 is 11. So if the length of one of the sides of the rhombus is 11, then the length of every side of the rhombus is 11. Questions? All right. Now we need to talk about a square. Definition. And this is from page 427. And I've kind of rigged it together in a different way. But on page 427, the definition says a square is a parallelogram. We know what that means, right? With 4 congruent sides. What other kind of parallelogram has 4 congruent sides? So didn't they just tell us that a square is a rhombus? And 4 right angles. What other kind of parallelogram has 4 right angles? Rectangle. So they have, in effect, told us that a square is a parallelogram, it's a rhombus, and it's a rectangle. It's all of those things. Okay? So all the properties of parallelograms apply, all the properties of a rhombus apply, and all the properties of a rectangle apply. So we don't actually have any new properties of a square other than the definition. It's just taking everybody else's properties. Okay? It's kind of like a superhero parallelogram. It takes the properties of all the other parallelograms. Okay? So, if there's a property that's true for a parallelogram, it's true for a square. Any property that's true for a rectangle is true for a square. Any property that's true for a rhombus is true for a square. Okay? So, when you look at this square right here, I mean, duh, square's what you thought it was, right? It's got 4 congruent sides and it's got 4 right angles. It's exactly what you thought it was. But I don't know that you had ever thought that it has all of those properties. So, in a square, do the diagonals bisect each other? Yes. Are the diagonals perpendicular to each other? Yes. Do the diagonals bisect a pair of opposite angles? Yes. Okay? Make sense? All right. Now, sometimes folks get a little confused with what property they can use for what figure and what they can't. And you may find this Venn diagram helpful. You may not. Some people really dig Venn diagrams. Some people don't. And most people are like me. They can take them or leave them. I see their purpose. I kind of like them. I don't have to have one. Okay? But it works this way. If this whole big box here, it contains all the parallelograms. You've got some parallelograms, like this one and this one, that have nothing special about them. They're just good old parallelograms. Okay? Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. The diagonals bisect each other. Then you have some parallelograms, these, that have 4 right angles. So that includes all rectangles and all squares. Then you have some parallelograms that have 4 congruent sides. So that contains all rhombi. Rhombi is plural for rhombus. Most people say rhombuses. That's also become acceptable over the years. So you'll hear me say both. And all squares. And then there's the most special case where all four, it's a parallelogram, and all four angles are right angles, and all four sides are congruent, and the only thing that's contained there are squares. Now, fortunately for us, the conditions for telling whether or not a parallelogram is a rhombus or a square are fairly straightforward. If the diagonals of a parallelogram are perpendicular, what's the only kind of parallelogram where the diagonals are perpendicular? A rhombus. Then the parallelogram is a rhombus. That's the converse of the property we had a while ago. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. That's the converse of a property we had just a minute ago. Now, this one you might not see coming. If one pair of consecutive sides of a parallelogram are congruent, the parallelogram is a rhombus. Now, I always think of this one as being a little bit like when we started proving triangles are congruent. We started off by knowing that we had to have 6 pairs of corresponding parts congruent, and then we narrowed it down to 3 with side, 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 and then side, angle, side, and so forth. The definition of rhombus says that all 4 sides are congruent. But think about it. If we know it's a parallelogram, then we know that side's congruent to that side, don't we? And we know that side's congruent to that side, don't we? So, all we needed was a pair of consecutive sides congruent, and we could just use a little logic to figure out, oh, the other 2 sides have to be congruent to those as well, because opposite sides are congruent. That make sense? So it turns out with just 2 sides, they got to be consecutive sides congruent, we can prove that's a rhombus. And then the next, if a quadrilateral is both a rectangle and a rhombus, then it's a square. So, no real special way to decide whether or not a parallelogram is a square other than if it's a rectangle and it's a rhombus, then it's a square. All right. Let's take a look at number 5. It says, given each set of vertices, determine whether parallelogram QRST is a rhombus, a rectangle, or a square. List all that apply. And then we're supposed to explain it. So let's graph this. So make an XY plane on your paper. And let's graph and see what it looks like. So Q is 1, 2. R is -2, -1. S is 1, -4. And T is 4, -1. All right, now, unlike the ones in previous sections where they would tell us what to use, they'd say use the slope formula, use the distance formula, they're leaving it up to us. And there is definitely more than one way to go about this, okay? But they want us to decide if it's a rhombus, then we'll decide if it's a rectangle, or actually we can decide if it's a rectangle first if you'd rather. And then if it's both, and only if it's both, it's a square. And I'd like to do this with as little work as possible, wouldn't you? That's not necessary. You can go about it the most inefficient way possible as long as you come up with the correct conclusion. That's fine. The one thing that I tend to use that students tend to not think of, at least until I point this out, are diagonals. Okay? You can go for the definition. You can find the length of those four sides using the distance formula and see if it's a rhombus. And you can find the slopes of the sides to see if the sides that connect are perpendicular and we get right angles to see if it's a rectangle. We can do that. There's nothing wrong with it. But this one works out kind of nice. See how Q and S have the same x coordinate, which makes that vertical. And notice how R and T have the same y coordinate, which makes that horizontal. Now, we already know it's a parallelogram, so we're not wondering about that. We know it's a parallelogram. If we have a parallelogram and the diagonals, one diagonal is vertical and one diagonal is horizontal, what's that tell us? They're perpendicular. What's that make it? It's a rhombus, isn't it? So, it's a rhombus since the diagonals are perpendicular. Now, is it a rectangle? And we could go about this, but we can see if each of the four vertices give us right angles. We can check that. But what is it that's special about the diagonals of a rectangle? They bisect each other, but that happens for all parallelograms. But he went further, said four congruent parts. And why, when they bisect each other, do they get four congruent parts? Because the diagonals are congruent, aren't they? Now, since they're vertical and horizontal, instead of using the distance formula, we can count, can't we? So let's find the length of QS. That'd be 1, 2, 3, 4, 5, 6. Let's find the length of RT. That's 1, 2, 3, 4, 5, 6. So the diagonals are congruent. What's our conclusion? It's a rectangle. Rectangle since the diagonals are congruent, is it a square? It's a square since it is a rhombus and a rectangle. Questions? All right. Let's do one more like that. Number 6. So we're going to use our properties to decide whether or not this is a rhombus, a rectangle, or a square. We know it's a parallelogram. And let's see. Let's graph this. So draw you an XY plane. Q is -2, -1. R is -1, 2. S is 1, 2, 3, 4, 1. And T is 3, 1, 2, 3, -2. All right, so that's what it looks like. Now, even though the diagonals will not be vertical or horizontal this time, I still think that's a pretty good way to approach these, okay? So let's see if the diagonals are perpendicular. If they are, it's a rhombus, okay? So, because I think, here's my logic. to me, finding the slopes of two diagonals is a little bit easier than finding the length of four sides. Okay? Now, do you think it's a rhombus? I don't think so. On my drawing, it doesn't look like a rhombus, but let's see. So let's find the slope of segment RT, because that's one diagonal. Let's find the slope of segment QS, because that's the other diagonal. And let's see if they're opposite reciprocals. If the slopes are opposite reciprocals, then the diagonals are perpendicular to each other. So for RT, using R and T, that'll be y2 minus y1 over x2 minus x1. I get negative 4 over 4. I get negative 1. Let's see what the slope of QS is. So I'm using Q and S this time. So y2 minus y1 over x2 minus x1. I get a positive 2 over 6. I get 1/3. Are negative 1 and 1/3 opposite reciprocals? No. So I can, well, it says, let's see, list all that apply. So I list nothing there. Okay? All right, let's see if it's a rectangle. And I think I'll use the diagonals again. Because at this point, I could either find 4 slopes. Ooh, actually, I can just find 2 slopes, can't I? Because since we know it's a parallelogram, if this has 1 right angle, it has 4 right angles. So I think I'll use slopes again, okay? So we know it's not a rhombus. Let's use the slope. How about let's find the slope of RS and the slope of ST. That way we'll know whether or not angle S is a right angle, okay? All right, so the slope of RS be 1 minus 2 over 4 minus negative 1, negative 1 over 5, negative 1/5. And then the slope of ST, let's see, that'll be negative 2 minus 1 over 3 minus 4. So that's negative 3 over negative 1. That's positive 3. So, not a rectangle either, is it? If it's not a rhombus and it's not a rectangle, can it be a square? No. So, none. And we still need to explain, let's say, the diagonals are not perpendicular, so it cannot be a rhombus. The sides are not perpendicular, so it cannot be a rectangle, so it cannot be a square either. So there's really not one technique to use to go about these. But diagonals are pretty good, and to decide if it's a rectangle, finding one pair of slopes is pretty good. Okay? Questions? All right, here's your assignment on page 431, 1 and 2, 5 through 12, 21 through 33, 46, 51, and 54.